Today we'll experiment that ammonia gas is also highly soluble in water. Okay, so what are the apparatus is required for this experiment? The first is round bottomed flask. Why it is round bottomed flask? Because the bottom of the flask is round. This is called round bottom flask. Okay. Second, the mouth of the flask is fitted with a rubber stopper. Here is a rubber stopper having two holes, one for jet tube and the other for a dropper. We can see here also that this is the round bottom flask. Okay, and here is a rubber stopper. This one is a rubber stopper where has two hole, which is for the jet tube. This is the jet tube and this one is for the dropper. Okay, so there are two holes in the rubber stopper. A trough containing red litmus solution. This is the trough which is containing a red litmus solution, because after the reaction this red litmus will be blue color. Okay, and a retort stand. Why the retort stand is used? To fix the round bottom flask. Okay, we can see here this is the retort. Okay, which is holding the round bottom flask in inverted position. The round bottom flask is inverted position. So I repeat, what are the apparatus is required? The first one is, we can see from the picture, a round bottom flask which has a rubber stopper having two holes, one for the jet tube and another for the dropper. Okay, a trough that containing red litmus solution and a retort stand used to fix the round bottom flask in inverted position. Okay, let's go to the procedure. The dropper containing water. Here is a dropper which is containing water. In apparatus we have seen that for a dropper containing water, that means inside the dropper some water is already contained. So the dropper containing water is squeezed. When the dropper containing water is squeezed, as few drops of water enter the flask, from here some drops of water will enter the flask. Now ammonia gas is present inside the round bottom flask. Okay, and which is highly soluble in water. So this ammonia gas will be dissolved in water, and due to high solubility this creates a partial vacuum in the flask. Why the water is dissolved in water? Because it has, why the ammonia is dissolved in water? Because it is highly soluble in water. So when the gas is dissolved into the water, so there are some vacuum, the pressure of the inside of the bottom flask will be less. Okay, some vacuum will be clear, so the pressure will be less and the outside pressure is high. So to fulfill the pressure gap, or to fulfill the balance the pressure, some the red litmus will enter into the round bottom flask. Okay, when through the jet tube, then we can see that a blue fountain emerges from this jet tube. Okay, I repeat again, what are the procedure? The dropper containing water is squeezed. So first you have to squeeze the dropper, that's all, you don't need to do nothing. As few drops of water enter the flask, ammonia gas present in the flask gets dissolved in water. Now due to its high solubility, why the ammonia gas will be dissolved in water? Due to its high solubility. Okay, now this creates a partial vacuum in the flask. If the gas will dissolve into the water, then there will be a vacuum in the flask. Since outside pressure is higher, the red litmus solution rushes up through the jet tube and emerges as a blue fountain. Okay, To balance the pressure, the red litmus rushes up through the jet tube and emerges as a blue fountain from this hole. It look like that fountain. So why red litmus is used? Because ammonia gas is basic. Okay, we have already learned that ammonia is a gas which is basic in nature. That's why it will change the red litmus into blue. Now some physical properties of ammonia. So ammonia is a colorless gas. Odor, it's strong, pungent, choking smell. Taste, as it's a base, so its taste is bitter. Okay, because the ammonia is a gas which is basic in nature. Now physiological action, it's a non-poisonous gas. Okay, but if inhaled it can affect the respiratory system and brings tear to eyes. It's a powerful heart stimulant and may cause death when inhaled in large quantities. It's a powerful heart stimulant, okay, and may cause death in when inhaled in large quantities. Density, its vapor density is 8.5, which is lighter than air. Nature, as it's a basic, so when it dissolves in water it gives OH minus ion. That's why it's a alkaline in nature. Liquefaction, easily liquefied at 10 degrees Celsius, only 10 degrees Celsius it can be liquefied. Okay, by compressing it the pressure is needed 6 atm. So at 10 degrees Celsius pressure is needed 6 atm. We can liquefy the ammonia gas. Boiling point, liquid ammonia boils at minus 33.5 degrees Celsius. Liquid ammonia boils at minus 33.5 degrees Celsius. Freezing point, solid ammonia melts at minus 77.7 degrees Celsius. Solid ammonia, solid, melts at minus 77.7 degrees Celsius. Now solubility, as we have seen the fountain experiment, it's a highly soluble in water. 1 volume of water dissolve about 702 volume of ammonia. That means it is more soluble than HCl, because 1 volume of HCl dissolve 452 volume of water, whereas ammonia, 1 volume of ammonia dissolve 702 volumes of ammonia at 20 degrees Celsius and pressure is 1 atm. Okay, pressure is 1 atm and temperature is 20 degrees Celsius. So liquid ammonia boils at minus 33.5 degrees Celsius. Solid ammonia melts at minus 77.7 degrees Celsius. That is solid ammonia melts. Solid ammonia, okay. And ammonia gas can be easily liquefied at 10 degrees Celsius and 6 atm pressure. Now we have learned the physical properties. Here the physical properties of ammonia. Now chemical properties of ammonia. The first reaction is oxygen. Okay, ammonia is not a supporter of combustion. It extinguishes a burning splint and does not burn in air. So ammonia is not a supporter of combustion. It extinguishes a burning splint. That is, a burning splint, we can extinguishes a burning splint by the ammonia gas, and does not burn in air, because air contain only 20% oxygen. Okay, it burns in oxygen with yellowish green flame. yellowish green flame. It burns with oxygen with yellowish green flame. This experiment we will demonstrate. So the reaction is ammonia with oxygen, 4NH3, 4 volume of ammonia react with 3 volume of oxygen. It produce nitrogen gas, okay, and water. Now what is the procedure? A white glass tube is fitted with a cork carrying two tubes. This is the glass tube, okay, it's a glass tube which is fitted with a cork. Here is the cork with two holes also here, one of which reaches just near the top, other remains lower. So carrying two tubes, these tubes reaches top and this tube in lower position, okay. Ammonia is passed through the longer tube, so ammonia gas will be passed through this tube because this is the longer tube, okay. Here the ammonia gas will pass, and shorter tube the oxygen will pass. Now a lighted match is applied. Now if we applied a lighted match from the upper, a lighted match if we applied, now what we'll observe ammonia burns with a yellowish green flame and produce water vapors and nitrogen as per the reaction, that is 4NH3 plus 3O2 produce 2N2 plus 6H2O, okay. Here is the reaction that we have already seen. So nitrogen gas will produce and water vapor will produce. It shows that ammonia contains nitrogen and hydrogen, because in water vapor hydrogen is also present. The reaction is irreversible and strongly exothermic. The reaction is not reversible. By heating ammonia with oxygen you will get nitrogen and water vapor, which is irreversible reaction, and this reaction is strongly exothermic. That means it will produce a large amount of heat. That's why a mixture of ammonia and oxygen are explosive and therefore dangerous.